Hello, welcome back to my bench. Today we're going to do a review of this multimeter and oscilloscope 2-in-1 Improve Your Work Efficiency MT8206 from MusTool. I got this from a guy that won it. He had no use for it, so he gave it to me. And I thought, you know what? Let's see if this thing is any good at all. There are several reviews on it online. But I thought I'd do it for you folks, my people. And we'll see if we'll put it through its paces and see if it actually does what it says it will do. The box says it's a multimeter plus oscilloscope 2-in-1. It's got one button automatic waveform capture, DC, AC, voltage, amps, ohms, millifarads, hertz, percentage, diode and continuity, real-time data and stored data on the same screen. And it has a relative value and auto-ranging. Nice. Oh, this side says it can store 100 sets of data. I wonder what that means. I did read the manual a little bit, so I didn't look like an idiot here. It says that overload protection, 500 milliamp and a 10 amp double fuse. Has an HD screen. Well, I'm kind of finding that hard to believe. Well, we'll see. Waveform data displayed is clear and intuitive. Memory calibration factor, no need to adjust. And, okay, maybe, okay. 15 minutes, no operation, automatic sleep. So it goes off in 15 minutes. And the parameters, what do we got? DC voltage, 400 millivolts is the lowest, I guess, and it has 4 volts, 40, 400, and 10, and 1,000 volts. Yeah, right. So it's a 4,000 count. AC voltage is 400 millivolts also, with 440 and 400 and a 750 volt max. DC currents 40 milliamps to 400 milliamps and a 4 amp and 10 amp scale. And AC currents 40 milliamps to 400 mils with the same scale. That's interesting. Resistance 400 ohms all the way up to 40 mega ohms. Whoa. We'll see about that. Capacitance, it says it'll go from 51.2 nanofarads full scale up to 1,000 or 100 microfarads, but then it also says 10 millifarads, so it'd be 10,000 microfarads. That's interesting. You don't get that in very often. Frequency 5 hertz to 5 megahertz because of the scope, I guess. 1.5 volts on the diode. Wish it was a little higher than that. Uses 3 AA batteries. Storage, it'll hold 100 data and 10 waveforms. And you can use it all the way down to 0C if you want to. Duty cycle 0. It'll display duty cycle from 0 to 100% continuity. Judgment resistance 50 ohms. I presume judgment resistance. It means it's judging it shorted at 50 ohms, I guess. And 15 minutes off. And has fuses 500 milliamp at 250 and 10 amp at 250. Okay, well, and it's made in China. So let's see what we got. Here we go. Well, inside the box you got a little package with the meter in it, I guess. Some probes. Normal old probes that you get with everything. And the user's manual. Not bad. I mean, it's got everything on it. including how to turn it on and off. Oh, we'll take a look at that. And we'll look for some interesting English in here. I see one already. It says innovative design for the one-key silent mode, quiet in mastery. Quiet in mastery. Features DC-AC voltage, resistance, capacitive to millifarads, frequency, duty cycle, diode, continuity. Some of this doesn't make any sense. It says multimeter with 200,000 analog to digital sampling and 4,000 counts auto range. One button switch from graphical to regular measurement. Reliable panel calibration technology. Memory calibration coefficients. You okay? Displaying historical data and real-time measurements on the same screen. Yeah, I saw that in here in the manual. Anyhow, take a look at probes. Yeah, they're definitely not silicon. These are just regular old probes, but they are safety probes with the shields on there, the rubber on the outside. They don't come apart. They're pretty darn sharp though. Yeah, not bad. I've seen a lot worse than those. And what do they say on them? Cat 3, 1000 volts at 10 amps. Cat 3. So Cat 3 is going to be one step before the device itself. I mean, the Cats, you got Cat 1, which is outside the house at the junction coming in. Cat 2 at the box, your switches in your box and on the wall. Cat 2 coming out of your AC plug and all that stuff, and Cat 1 is inside your device. So this says Cat 3 at 1000 volts. Yeah, no, I wouldn't trust him for that. But you're not going to use this kind of a meter on 1000 volts to begin with. I mean, come on. All right, so it comes in a little bag. There's some strong material. Nice little bag. Don't know what you'd ever use it for. I mean, you just have to dig it out. And it comes in a plastic bag inside the bag. And there it is. Well, it doesn't weigh much. It's pretty light. Okay, what does it say on the back? It says Cat 3 at 600 volts. And Cat 2 at 1000 volts. Okay, so the meter itself, Cat 3, 600 volts in the box, and 1000 volts at the plug. I don't know. I think 110 maybe would be the max I'd want to go with this thing, or maybe 220 overseas. We'll find out how it works. It's got a nice positive switch. Off on both sides. That's kind of neat. And it's got millivolts DC, volts DC, volts AC. That's interesting. I don't see millivolts AC. Hertz and percentage. And then a multi here for switching, I guess, with select between ohms, diode, continuity, and capacitance. And a millifarad selection. Milliamps AC and DC, and amps AC and DC. Okay. And your general things down here, except for it's got this milliamp and millifarad. That's interesting. So down here, let's see, on the back it said Cat2 1000 volts. Here it says the same thing. So between these two, you got Cat2 1000. It's got max 400 milliamps fused and max 10 amp fused. So, let's see. I got a couple of batteries, which I have prepared here. These are rechargeable batteries. So they're only going to be like 1.4 volts. And how do you get the batteries in it? Oh, okay. Well, the batteries case is very easily accessible. It's right underneath the stand. Stand's pretty wimpy, and the thing will slide right away from you and tip over. Not good so far. What did that say on here? Okay, it says 1. Install the A and B. Install the 2 outside ones, and 2, install the C. So there's directions on how to put these batteries in. All right, we'll do it the way it says to. There's that one, and that one, and that one. Okay, well, cute. Let's see what happens. We'll turn it on. Auto power on, quiet mode off. Wow, those are some big digits. And the whole thing, I mean, it lights up. That's bright. So, I mean, even if it's just flat out dark in the room, I mean, it's... You don't have to worry about being able to see it in a dark room, that's for sure. So I'm on millivolts. It's flashing all over the place. Volts... That's DC, there's volts AC and auto, DC and auto. It tells you everything right up on it. Hertz, 0. And we got ohms. I guess it's select. It beeps at you. It went into diode mode. And it's instantaneous on the button. You don't have to hold it down. It's got the beeper for continuity. And auto on capacitance. That's cute. So, auto on ohms. Millifarad range. Milliamp range and amp range and off. Like I said, it's off on both sides. That's cool. Alright, well, I guess let's try the basics first here. How do they fit? Well, they fit nice. Let's go up to ohms here. No, okay, there we go. So, how fast is it? We'll go from 0 to shorted. 1001, okay, so about a second. That's not fast, but that's okay. We're in diode mode. It's even faster. And let's go in, okay, this is the continuity. And we'll see how good it does on continuity. Oh, wow. Wow, that's fast. That is almost instantaneous. I can beat it, but you wouldn't. I mean, if you were measuring something, it's right away. And it locks. That's nice. Well, that's one thing in its favor. And these are just the crap that came with it, leads. Okay, well that's not bad. Let's find a capacitor here. What have I got? Not quite prepared. All right, let's go for some Let's go for voltage first. Okay, DC volts. I got a supposedly fully charged lithium-ion battery here. And we'll go negative to positive. 4.19 volts. That's pretty quick. Does a few steps. It goes like 2 steps to get there for 4 volts. Reverse voltage. Same thing. That's pretty good and fast. All right, well, let's try AC. Hope I don't blow myself up. Here we go. It's telling me that it's high voltage. It's got the little thingy up here. 121.3 volts. That's not too bad. That's pretty quick. Yeah, that's fine. Hertz. Well, let's try Hertz right in the plug. 59.9. That worked nicely. And back to 0. So I didn't blow it up. Capacitance. This is the one that'll be interesting here. I gotta find the capacitors. Some capacitors. Let's see. Here's a... Just want to find a little one. What's this one? 104. 10000. 10,000. So that would be, what, a 0.1? Yeah, so... That's an annoying beat, but I guess it's okay. Alright, so we got 10,000. See if I can keep it in view for you here. Stay. It does not stay with a damn. It's too light. But... 115 nanofarads. That's correct, and it was pretty quick. $115 nanofarads. Well, accuracy-wise, I know that this thing is accurate. See what it says. There's 200 nanofarads. 113.6. Well, 0.4, 0.5. That's pretty good. I'd say that's probably within specs, although they didn't say what the specs were so much. We'll look that up later. Okay, so what's next? Oh, big one. So here's a 3300 microfarad at 50 volts, brand new cap, and we'll see how this works when I hook it up. I have to. What do I have to do? Hold on, I gotta look this up. There we got the manual. So we got what? Insert the connection plugs. Red test probe into the positive jack. The other one into the volts ohm cap jack. Okay. Rotate the function switch. Okay, over to millifarads. And what? Okay, I guess they want me to relative the thing out. Yeah, well, don't need that. Not here. And hook that up to there. Come on. That one to there, that one to there. And give it some time, I guess. And there we go. It says 3.1 3.175. And that's 3300. Let's see if I take let's take this guy, because this is the only other thing I've got that'll read that high. Little voltage. One of these days I'm going to build a power or battery thing for this. Okay, yeah. Let's see, let's put it on capacitor only. And 100 hertz. Get that out of the way. Can you guys see that? I'll pull it up when I can. There we go. And hook it up and see what it says. So it says 3.059, 19 milliohms, 87. So yes, 3.059 microfarad, or millifarad, so 3,000 microfarads. And this one was what, 331 something overload. It beeps at you very loudly if there's any voltage left in the cap at all. 3.18, 3.05. I call that good enough. So it does read very high capacitance values. Well, that's cool. Okay, well, now we've got the caps done. Let's do some resistors and find out if this thing is accurate. We'll put U on ohms. We're going to pretend that this thing's accurate-ish. It was last calibrated in 2008, so we're going to go with it there. Let's start off with something low first, like 100 ohms. Here we got 100 ohm resistors, I do believe. I think so. We'll find out. Put it back here. Oops. Okay, that's on ohms. And let's take here and here. Put it in the right slots. Got to remember to do that. Okay. It says 100.5 ohms. Alrighty, let's look at this guy over here and see what it says in ohms. Oh, that's right. Ohms goes by the other one. Yeah. What have I got here? We can borrow you for a minute. All right. Clip the negative or the positive there. And I believe the negatives are the same. So we'll put this one here. Maybe they're not. Maybe you have to use this one as common when you're doing voltage or ohm voltage resistance. So we'll go there. Did I pull the wrong? Yeah, I did. Wow. That's what happens when you have too many leads around. Okay, clamp. 100.7. And what did this one say? Um, 100.7, so that's right on. Okay. Very good. Let's go up a little bit. Let's go to 10K, because that's what I got out here. This one is not as accurate as the others. This isn't a 1%, is what I'm saying. Okay, so 9.96K. Okay. And the fluke says 9.91. So it's 4 out. 4 out, 9692. So it's 4 out. So that's good enough. That was stupid. In 10K, sir. And let's try 3.9 mega ohms. So remember, this thing says it'll go to 40 mega ohms. I haven't even got anything that high. This one I have to be able to put down here and do it. So come on. Get on there. 3.96. I don't know if the fluke will even read that high. 3.96. 3.95. I'll go with that. All right, the biggest I got's 20 megs. Let's give it a shot there with the little scope or little meter. You can't see that anymore. Okay. And we got 20.0. So 20.0 megs on this little meter. And the fluke, I don't know. Yeah, fluke's reading 1.990. Unless I get a better... Okay, we're going to say 20. So yeah, this little guy is accurate on 20. 20 megs. Wow. So, resistance is pretty good. That's, I'm kind of surprised. So far, I'm kind of impressed a little bit. All right, well, let us, now that we've gone through all of those little steps, how about the graphing portion of it? Took me a while to figure out reading the book, but okay. Plug this guy in up here. And this is coming out of the function generator, which we got right here. See it? We're on sine wave, 1000 hertz. And we got to switch these guys back around to where they go. All right. So, what do we got? 1.6 volts on auto, on AC voltage from 5 volts. That's approximately right. Let me hook this guy up here for you. Okay, I have no idea what's dying on me here. Everything's still working, near as I can tell. Probably not a camera that I'm not using anymore. Let me get rid of that. Maybe that'll help. Let's see. So, anyway, we got it all set up. We got 1.6 volts RMS, DC, 0.016. All right, so let's go to here. All right, now let's go to our little scope. And look at that. We got 1,000 hertz coming in. It says 0.998 kilohertz, so that's 998. 1.6 volts up there. That's good. If we take it down a little bit, we can get a little more on the screen. If you go too far, it gets really crappy looking. It's got to be reasonably small number of waveform on there. Anyway, so we got that. Well, it looks okay. Let's take the our function generator up. 2.4. Yep, still looks good. 2.3. And 1.51, 1.592. This says 1.68. But let's go to this meter here. It says 2.4 kilohertz at 1.626 with a pretty decent looking waveform. So, yeah, it's reading. This is reading it right. This is 2.39. Close enough. Go up to 3600. Drop it down one. 3600, 1.6, 1.588 at 3600, 3.6 kilohertz. Like it. 4800. Looks good. Still says 1587. So that's off a tad bit up there, but we'll just leave it there. I'm not going to get in and change anything. And if we go up one more, there we go, 5.99 or 6 kilohertz. That says 5960 or 599 there. That's good. 7.2, 1.6, 1. Nothing's changed. 7.18. That's good. Wow. 8.4. 8.38, 8.4. That looks good. 9.6. 9.57. Get rid of a few of them here. It's effing back and forth a little bit. And this says 9.6. So we still got the right voltage, or the same voltage up there. There's 10.8. 10.8 looks good. So, hey. 12. It's getting a little wishy on the tops of these guys up here. It's not what I would call clean, but it's still got the right voltage and still saying the right thing on kilohertz. So 13.2, yeah, maybe not. Okay, it's getting. Okay, that is as fast as it'll go. So you can still see it. It says 13.18. This is 13.2. Still within it. Still the voltage is still good. But I don't think it's going to go to 14. Well, you can still see it. 14. I'm looking at 14.4. It says 14.37, 14.39, 1.6, 1.582. Wow. Okay, 15. Ooh, it's getting ugly. It's getting ugly. 16. Yeah, that's as fast as this thing will go. I can't. Yeah, that's it. It just won't go any faster. So, well, let's keep going. 18. Nope. Oh, wait, it did catch up. It says 17.96. And it still is a waveform. 18, 1.6, 1.582. Wow. I'm a little more than impressed. Okay, here's 19.2. This thing says it'll go to 20. 1916. And I don't think that waveform is not changing any. It is, let's see, let's go back one. No. The waveform gave up at 16.7 or 16.8. Yeah. All right. And there's 20 kilohertz. See if at least it'll read it here. 20.361582. So the voltage is staying the same. 20.420. Yes. All right. So it reads those just fine. But what's the 5 megahertz they're talking about? I wonder. Hold on. Let's go to hertz. It says 20.39 kilohertz to 20.4. I'll bet you that the 5 megahertz is this one. Yep, 4.998 megahertz. If I go back to here, it's going to overload. There's no way it's going to read that. It's just locked. It doesn't care. No voltage, and it says 2 kilohertz. So yeah, no way. But yeah, it won't read that. So the 5 megahertz that they're talking about is on the on when it's reading frequency, and let's see, and 51.5% duty cycle. Cool. Well, it's a sine wave. How bad could it be? All right, so that proves that. So now we know how that guy up there functions. But what we got to get now, the one last thing to do, is we want to see how you save things. So let's get the manual back up here. Where is it? Oh, that's what I lost. Hang on a minute. I'll be right back. All right, so the manual went away for a minute. We want to see how to save our functions in this, or save our readings. So let's see, where's that at? Oh, wrong place. Okay, up here. Display operation, measurement, saving and reading signal waveforms. All right, so what does it say to do? It says go to there, go to there. Okay, so we got our 4.9 4.99 kilohertz at 1.585, 5 volts peak to peak. And it says to press the hold button to enable waveform hold storage. Okay, it says a little HO here comes on, and then press the hold button for more than 2 seconds to enter the waveform database. Okay. The location of the 10 waveform groups fills from H0 to H9. Oh, okay. All right, so we go. All right, so it stored it in H0 automatically. And if I want to get out of here, do that. And then let's say, let us let's change our frequency here to 8.4. All right, so that's 8.3. If I press and hold, that puts me in H0. But if I press and hold again, wait a minute. H1. And then press and hold. So if I press here, H1, no. All right. Oh, okay, yeah. It stored the last one in H1, and you can go back and forth between there. All right. And then to get rid of them, it says to press the DIS button for 2 seconds. Oh, no. Oh. You probably have to be in the hold mode. Nope. Okay. Hold. Hold. No. Okay, now I'm in the... Yes. So I've accidentally stored 4 of them. And then if I press and hold this, the little trash can comes on. And I hit that. And they're all gone. Right. Okay. Well, that's, once you get the buttons going, that's not too bad. Let's get out of here. And you do pretty much the same thing here. You press, if you want to keep just the voltages, you press that. You press that, and it'll store it in the next available. Okay, so let's change our voltage to DC. Press and hold. So, okay, that's hold. Okay, now, okay, so you just short press it to get it to stop, then you press and hold it, and then it holds it into your, okay, I got it. And I guess the same thing, you hold this, trash can, press that, and they're all gone. Well, that's interesting. That works pretty well. I like it. Not a bad little meter, but it's got a few flaws. So I guess now our best bet, let's take it apart. You know, before we do that, I want to check something else. Let's put this back in AC. I want to see what it does with other waveforms. So let's get the function generator back up here. And let's give it a different waveform and see what that says. How about a square wave? So what am I at? I'm on 8400. No. Let's be nice to it. Let's do it at 1200. Just because. Okay. And let's give it a square wave. See what that does at 1200. Not bad. I do wish it had the ability to read your voltages out here, because this is giving me 2.515 volts RMS, and 1200 kilohertz, but I can't read the voltages here. It does say that it's crossing the 0 mark. We're in voltages DC or AC at this point. All right, so let's try. I don't know. Let's try a triangle wave. That's pretty triangular. How about a ramp? Yep, there's a ramp. Reverse ramp. No problem, probably. Yep, reverse ramp is fine. DC. Boink. Straight in the middle, nothing to it. It's just straight out. What do we got? It shows something, I don't even know what that is. Let's try an AM signal. Well, it actually looks like an AM signal. Wow, I'm kind of surprised. So let's do FM at 1200 hertz. Yeah, no, that ain't going to happen. Okay, I didn't think so. What else we got up here? How about Lorenz? Ooh, it likes that a lot. Well, so it'll read them, 1.198 at 1.296. This thing says 1.4, 1.3 to 1.4, and 0.95. All right, let's go to DC and see what that looks like on DC. 0.937, 0.944, happy with that. Ah, look at this. negative 0.9 volts, and it is coming up on the little scope here that it's on the negative side. Well, that's nice. Let's go back to our sine wave. That should put it in the center. It is. It's not very big, and there's no way to make it bigger. But then it's not much of a voltage either. However, what I wanted to test was, let's try our bias voltage and see if our bias voltage will do anything. Let's give it 2. Yes, it does. The bias voltage goes right up there with it, and it shows you whether your bias is on the high side or the low side by 1.884 to 1.906 plus. So how about, let's do a minus, see if that works. Sure enough did, went right down. Sure enough did. Minus 1 point, that's 1.7 volts, minus 1.7. It doesn't say up here that it's minus next to the digit, though. So that's a good thing it does show there. If we go back out to here, damn it, there, it does say minus there, 1.799 versus 1.813. So yes, and it even shows the what side of the center, the zero crossing line you're at. Not bad. Not bad at all. Well, that's cool. So now we know how that works. Let's take it apart. So let's get everything out of the way. And of course, we got to open it up. Of course. Where's my screwdriver? Here it is. There's just 4 screws. Little. Whoop. Head's too big on that. Okay. And they are definitely in plastic. What size screwdriver? But they're definitely into plastic. They are not into metal. But what do you expect? It's $50 meter, I guess. It says it's fused. 3 of them, actually. Open it up. All right, well, it does have sort of, it doesn't actually go inside the case, but it goes up past the lip of the case, so it's not just open for flash protection. And what fuses? Where? Oh, okay. Fuses. What's this one? This one is the 10 amp. And these little guys under here are the 500 milliamps. Well, those aren't replaceable unless you know what you're doing. Don't like that. That's, yeah. No, those have got to be replaceable fuses, guys. That's not good. You got one protection here, another one here, and that looks like about it. And what about these things are just, they're the El Cheapos. They're, the spring split ones. They're okay. They work. And they're just soldered right down to the board. and they're not actually, if you look at it. So a lot of taking in and taking out is going to break those at one point or another someplace down the line. It's got, the battery holder is actually affixed. So it's actually physically on the board. And it appears to be glued down. Yeah, it is. Got a big old chip up here. What is it going to be, I wonder? Where is my... It's a CS7721CN by Semic. Alright, and this one is a HC32L136. I'll look those up and put a little thing up on the top there. I don't know if I want to take this out or not. No guts, no glory. Little tiny screws holding it in. The only reason I'm wary of taking things like that is if this is... Here's a little beeper, and it's good and loud, by the way. I do like that. If this thing's held in, all done with zebra strips, depending on the age of the device you're trying to work on, zebra strips can be a little bit finicky about putting them back. I have found the best way to clean them, though, is with a eraser and a number 2 pencil, and then follow that up with a cotton swab and some alcohol. All right. Not as it, well, it might be, but it's not coming off. No, it's soldered down. All right, well, there is practically absolutely almost nothing on the bottom of this, period. This guy is run by serial. Got your 4 pad positions. Those are not too bad. The pads are more than just one stripe on them, so they do make well. That's good. Plain old copper, just copper, and copper. Nothing special about the switch either. And these guys just floating around the breeze. And there's your 10 amp resistor, basically, for your 10 amp measurement, which goes right to here, which goes on up into the rest of the guts. And it does have some cutouts for voltage. They did do some they cared a little bit. They put a couple of cutouts here for voltage and across the fuses. Not across the big fuse, but, well, okay, make sure there's nothing else in there. And I did notice that there is a space for something else on here. I wonder what it would be. Get back in the hole. There we go. There's a space for another crystal up here, and I wonder why they need another crystal. This thing's pretty full. Oh, and there's your JTAG, I presume, right there. Okay. Well, put it all back together again, see if we ruined it. I don't think so, since the screen didn't fall off. So as I'm putting this together, what do I think? Well, it's not an oscilloscope by any stretch of the imagination. It's a graphical display meter. Is the graphical display useful? Well, in a couple of ways, yes. It does give you can take a look at your waveform and see what it looks like. It's not perfect. And it does take a little finagling around. The automatic on it is not great. You have to play with it and get it back up and down. It will display okay up to about 10 kilohertz, or maybe just a little less. But that's okay if you're doing audio work. It does the AC. The fact that the DC will show the offset, that's nice at a glance. Now, because the thing, there's no, they don't tell you what values are along the vertical scale, the voltage scale. That's no good at all. But at least it does give you a representation of it's above or below the line. But and it does have that very, very fast continuity test, which is good. I mean, that's very good. So for $50, I wouldn't want this to be my only meter. If you're going to use it as a throw it in the bag when you're out type of thing, for real quick measurements, and okay. The fact that it does have that really big capacitance sector selection on it, though, is, I mean, I've only got two things that'll do that. Well, one that'll do it without this. I mean, I haven't got anything else that'll read that high accurately. That's good, but still, I don't know. It's built pretty cheap. The fuse situation is just stupid, guys. MusTool. I mean, really? You can't change the fuses without unsoldering surface mount fuses? Nobody. You can't expect people to do that. Put real fuses in it. I mean, MusTool doesn't watch my videos, I'm sure, but I mean, wow. Okay. It's a fair meter. It's better than I expected by quite a bit. I like the instructions on it on how to put the batteries in. I think that's cute. It's better than I expected, but it's also less than what I wished. The fact that it has no way of holding still, that's awful. At least, it sort of doesn't want to tip over. There we go. Auto back on. Would I spend the money for it? No. Not the way it is. I mean, I would if, two things. If they gave you the value, if the Y scale here had values on it, and you were able to, when you put something on hold and you went back and looked at it, did we save anything in here? No, we didn't save anything here. And you went back and you were able to look at it. If you could expand it out a little bit, and if the fuses were replaceable, yeah, I'd say it'd be worth the $50. Also because it lights up like a Christmas tree and it doesn't need a backlight; it's just there. So that's what I think. So it's in its present shape. It's not a buyer. It's not something I would throw money at. But if they did a couple of things, it might be worth it. Anyhow, folks, there you go. In-depth review of a MusTool Graphical Multimeter. See, they even call it a Graphical Multimeter. MT8206. Nice little box. Great idea. Not quite grown up enough for prime time. Thanks for stopping by. Don't forget to subscribe. Ring that bell if you want to see more of this stuff. And don't forget, I got a Patreon channel, AERV blog on Patreon. If you feel like supporting me for what I'm doing here. Till next time.